Okay, let's give you guys some practice. So this line here, is given by this, and this line here is given by this. So this area here corresponds to this area here. So this point here corresponds to this point here. So when you rotate this 360 degrees, is you rotating this 360 degrees here. So as you rotate this 360 degrees, you're going to create a hole in the middle here. So as you rotate this 360, you're going to create a hole here, and as you rotate it 360, you're going to create this same hole. So it will look something like this, and there will be a hole that goes all the way through. There will be a hole that goes all the way through here. Okay, so when you rotate this this area here, when you rotate this along the x-axis, it will create this solid here. Work out the volume of this solid. Okay, so press pause and have a go. Work out the volume of this. So press pause and have a go. Okay, so to do this, we're going to sweep through from here. We're going to sweep through all the way across. So we're going to need this point and this point, because if you look at this particular slice here, when you rotate this 360 degrees, it will create so when you rotate this 360, it will be you doing this all the way through 360. Okay, and then if you look at this point here corresponds to this point here. When you rotate this 360, it will create something like this. So that's when you rotate it 360, it will create something like this. So what you have here is, it's like a washer here. Okay, so what you have here, will be like this. Hang on, it will be like this. So this here will be this radius here. This radius here will be like your f of x here, and then the small radius here will be your g of x here. Okay, so this is your g of x. So you've got to work out the area of the big circle. Work out the area of the big circle, and then take away the area of the small circle. Then that will leave you with what you want, the area of this one particular washer here. Okay, so anyway, to work out the volume of this, here, we're going to need this point and this point, because we're going to sweep it through all the way across. We are going to sweep it from whatever point this may be to all the way to this point here, whatever this may be. Okay, so we're going to need this point and this point. So blah blah blah. That will then tell you that this here must be -2. This here must be +1. So this point here. So this point here will be -2, and this point here will be +1. Okay, so we're going to integrate it from -2 to 1. So what we're doing here is we're going to integrate it all the way through here. Okay, vertically. So from -2 to 1, and then if you look at this one particular slice here, we're going to need the area of the big circle, which will be pi r squared. But this r here, the radius of the big circle will be f of x. Will be the radius of the big circle will be that. So hang on, let me think. Sorry, hang on. The radius of the big circle is not this, because this here is our quadratic here. The radius of the big circle would be g of x here. Sorry. So it will be g of x here. So you put this into here, Because if you think about it, as you're sweeping through, this is your big radius, and this here is your small radius. Okay, so it would be the big radius. So the big radius would be this. So you've got to put it into here. Okay, and then take away the so what we've got here is we've got the big radius. So the big radius is g of x here. Okay, so you put this in here. Take away the area of the small radius. The small radius would be well, if you look at this particular washer here, the small radius would be from here to here, which happens to be this quadratic. So you put this into here, and then follow it through. So so pi is a constant, so you can actually take it out. You can actually take it out here, and then just concentrate on integrating this, and then blah blah blah. It should give you this. Okay.